butchering his name. He's the platform engineer at Docplanner, and he's gonna be talking about the implementation of GitOps in our company with the use of Argo CD. The other guy is Jorge. He's gonna be talking about KEDA. He's not only one of the MVPs in Docplanner, but also the Microsoft MVP for the 3 consecutive years. But he's gonna be talking later, as we are all afraid that he's gonna take forever, as he can talk about KEDA like without ending. Yeah, I guess without further ado. Oh, and me myself, my name is Wojtek. I'm a data engineer at Docplanner, and I'm just a host, so you may as well treat me as R. Yeah, since I don't have anything else to talk about, let me introduce you to Jean. The scene is yours. Share your screen and start talking, man.
Okay, hello, my name is Juan, and I'm going to talk about how we approach the GitOps changes here in Docplanner. Also, probably you can have different approach. It's important to take into account that this is how we are dealing with it, and we are also learning how to improve. So, as always, there are sometimes that you have to fail and continue, no? Okay. So I will, as Wojtek said, I work as a platform engineer. I'm a passionate person about cloud technologies and Linux, and in the last year I have been focusing in this. Really, in Amazon, I get certificates from as solution architect, and also in Kubernetes, especially in the last 2 years. No. Okay. For talk about Argo CD and GitOps, we have to first introduce some terms that we are going to be using during all the session. No. The first is the CD. The CD shortcut. Probably some of you have heard about it. But it's important taking into account that the CD card shortcut is being used for with 2 meanings. One is the continuous delivery, and another is the continuous deployment. The continuous deployment is a software approach that is being used to deliver constantly new features in software, and is being totally automatically. As you can check in the second part of the picture. The last part, that is after the test part is okay, it automatically is going to go to production, the chain. But the continuous delivery is another approach that basically differs in the last step. That to deploy, there is a manual intervention, a manual action to do. And if we focus now in the GitOps part, GitOps is a term that was introduced by a company that is WeWorks, that is really focused on the GitOps ecosystem in 2017. And it defined it as a set of practice to manage infrastructure and application configuration using Git. No, basically the main idea behind GitOps is that the through of the application is in Git. So the Git repository is going to have the actual state of everything that is deployed in Kubernetes. For dealing with that, there are what is called in software agents. There are different approaches and different software that can do that. That basically what are doing is they are monitoring the Git repo, and when there is a change detected in the repo, they have to reflect this change in the Kubernetes cluster or cluster. This depends really on the software. And for that, what you can check in the picture is that there is a GitOps operator, no? That really is what Argo is doing, and we are going to explain later. So some good benefit of this is that the Git repository is going to contain the system, the actual state of the system. So when there is a drift between the Git repository and the actual state in the Kubernetes cluster, the response this GitOps operator is the responsible to reconcile the state between them. And there are several tools for this, but we decided to use Argo CD because it's the best that fits for our use case and our infrastructure and all that is related. And what is Argo CD? Argo CD is a declarative and GitOps continuous delivery tool for Kubernetes that is basically using again, as I mentioned, the Git is the source of truth. And for that is deployed in Kubernetes, the application or the applications, and it can be stored in several ways. It can be JSON-net, Helm manifest, or directly YAML manifest. No, to do as we do a kubectl apply normally, it's the same. No, there are YAML manifests. Anything that they can be understand to deploy as a Kubernetes application. And Argo CD is implemented as a Kubernetes controller that is monitoring all the time the change in the repository and deploy in the cluster or in the cluster. This is also really important. When there is a change detected, the application changes the state to sync to auto sync, so it's going to try to reconcile the state again, and the normal state will be sync again. If there is normally is done automatically, but also for some application that you can control it after a new change is detected, the change is applied, no, especially for very sensitive applications. This process can be changed to manually. And also something really cool about Argo CD is that you can deploy Argo CD in one cluster or in several clusters, and you can connect several Kubernetes clusters that can be in different regions. As in the image is shown in the bottom, you can directly deploy the application and say, okay, this application is going to be deployed for production in these clusters that are in these regions. Also, something important to take into account is that Argo CD is only a project of the Argo organization. No, they have a lot of interesting projects, all of them focusing in Kubernetes, as you can imagine. There are, for example, Argo workflows that is really focused on the create workflow for CI, for a complex CI, CD like Git actions. Something similar is the same idea behind. And Argo rollouts that basically is the complex deployment procedures that are like blue-green, canary, many of them that you probably have heard. There is no a simple way to do only with Kubernetes. So you have to have other software or other tools to do it. So Argo rollouts help you to deal with the type of deployment procedures. And Argo events is to deal with events, with hooks, to do, for example, action in a S3 bucket or something like that. I don't want to extend more. Sorry. And Argo CD is the first that I say it does it declarative, and this is a screenshot of an Argo CD application. No, it's a manifest of Kubernetes that have a specific kind and application. Also the API version. No, we have to take into account that it's a CRD, a custom resource definition, and then you can specify, as I mentioned, how you are going to store the manifest. In this case, we are using an example of the Argo CD examples, but it's a Helm, no? So we have to configure the typical things that we do with the command. The release name, where are the values stored, what is the path, no? Because you can specify specific paths, and the sync policy and or regarding. Also, something important that I didn't mention is that you can, in a simple way, you can configure the notifications with Argo. And after configure, there is a component that before it was separated from Argo and now is inside the Argo CD itself. That is the notifications part. It is only an example. In the line 5, you can see that every time that there is a thing that is a feed, is going to notify to this channel. But there are several templates for that, like the typical failure, when there is a timeout, and all of them. There are a lot of them predefined that you can directly use. And now I would like to explain what was the TD changes that we did in Docplanner when we started to work in that, no, and that we are continue working on. The initial state of the CD it was not uniform, no. It was a lot of tools, not a lot, but many tools like Buddy. Probably not all of you know, but it's another tool like Azure DevOps or GitHub Actions or something like that, and more powerful than maybe GitHub Actions some years ago. So we have these tools, no, Buddy, Azure DevOps, and GitHub Actions. Really, GitHub Actions more focusing JavaScript projects and projects that there are more centered in sync, the change in bucket or something like this, no. So we have some straight problems that it was really difficult when there was a problem with the deployment processor to know what is happening, because we were not having a clear tool or a common tool. And also it was when you have to start a project, really you don't know what tool to use, no? And also there wasn't any template. You have to create from scratch, copy and pasting from other projects, or then there was error because some variables were hard-coded, and no, the typical problems in this type of situations. So the changes that we need to deal with is the first, we need to define common tools for the CD process. Instead of having several tools, we have to have common tools, and not only common tools, or let's say a common tool, also to have flexible flows, no, because it's not really the same deploy a .NET application, for example, than a JavaScript application, and also depends if it's a backend application or is a front application. But having like some flows focus on the language and on the way of deploy, it will help a lot to deal with the problems and also to create new projects, no? And also some problems that we have to take into account is that we need to have a mechanism to deal with a disaster recovery. So we need a mechanism simple in the way that we can, and also reliable, of course, to restore information when if everything goes down. We need to have a quick way and reliable way to restore the application, no? And Argo CD help a lot to that, because it's got the repo and it's going to deploy, no? After a lot of discussions, not a lot, but after some discussions and some proof, we finally decide to have this common. No, I'm going to focus more on the CD part, but really talking about the CI and CD. No, this common flow is flexible. There are some things that they can change a little bit, but this is the main idea behind. Every time that in a Docplanner application, it was a pull request that was merged to the typical branches that we use for here and in mainly a lot of companies like develop and master, no, to deploy to testing and production environments. As part of the CI, the test was a workflow for test was running, and if the tests were okay, we can build and push the image, you know, because this is the CI part. They can be also, we are adding more workflows, but this is the main idea. So the TD, every time the commit we say that is safe, go to production or go to testing. Every time we merge this, we update the Argo CD app. So we get the commit tag that we generated before, and we promote that commit and put in the Argo CD apps. Argo CD apps is really only a name, but what is in this repo is a monorepo where the configuration for the Argo CD applications are stored. Because for the way of working of Argo, it's better having a monorepo and having several folders for each application is where you can use the path that I showed before, and then the values. You put, for example, apps folder, and inside the apps, you can put every app 1, app 2, and inside you can put the configuration. So in the specific path of the app that was outdated or a change was promoted, you update these values. So what is going to happen is that Argo CD is going to detect this change. A webhook event is going to be triggered. So Argo CD is going to reconcile the state that there is in the repo with the state that they have to do in the cluster or in the cluster, because we can deploy to several clusters, and we have, of course, several clusters. And after that, if everything go okay or everything go wrong, we will receive a notification in Slack. And here is only an example of a real execution. In the left, we can see a test. With the commit, we can see that it's the same commit. So after this, the build and push run that is going to build and push the image to the Docker registry. And the last, let's say the result. This was the result of the CI, and the result of the CD is that the application is deployed. So we can see a lot of results, but the most important is here we can see the deployments, and we can see in a quick way the last pod that is created, and also the CCI that we are using, because we are using Bolt and we are integrating with the CCI secret, because it's a good way to do with using Kubernetes native components. Is one I didn't mention before, but one of the reasons that we decided to use Argo is also this, because it's really powerful and at the same time simple. View the change of an application, what is deployed by an application in all the Kubernetes cluster. So it's also important. But after that, we decided that we need to also improve other things related with the development environment and with the CD process. And here is where Backstage comes in. Backstage is an open platform for building developers portals. The idea behind is that try to unify all the tooling, all the service, and all the documentation that you have in a company in a single and consistent UI. Also similar to what Argo do to applications with Kubernetes. Not necessarily the same, but it has a really powerful UI. At the same time, it's simple for doing that. And the idea behind is that there is Backstage gives you like a core component, and you can extend. You can use a lot of plugins, and you can extend as you want. You can incorporate your own components. Is the core idea. And Backstage was created to Spotify, and after some months, it was donated to the CNCF. And some months ago was promoted to an incubation. So now it's an incubation project. It has a lot of users using, a very good community behind. We are also contributing with creating PRs, talking with them. So it's also important. And there are some benefits, some clear benefits after adopting Backstage. One of them, and let's say one of the more connected with the topic of the talk, is that it improves a lot the creation and configuration of some internal processes. Because, for example, when you create a project, you have to create a project, the database or infrastructure parts, create some channels in Slack, if you're using Slack, or some alerts, okay, and connect between them. So Backstage helps you to do that, and also to do anything that it can be done in a programmatic way. Also, it's helpful to have a standard for the definition of processes because it's something that we miss in the changes that that I mentioned before. Also, it helps you to have, for example, a predefined process for configure the CD in application or application itself altogether. And also increase the internal visibility because the portal, I will show you in the next slide a screenshot. It's really great for that, for having a quick look of the components, how are the components, who is responsible for, what is the type of the component. This is what I mentioned. This is the software catalog. The software catalog is a component of Backstage that is really a centralized system that is going to keep track of everything that is deployed with Backstage or inside, let's say, with inside Backstage. How it works is having a YAML file in the repo. You only have to put a YAML file with some metadata that Backstage is going to keep track of. After pushing this, you can see the name of the project, what is the owner, what is the type, and also what the description. You can also put some tags. And so this is really an extension from their demo. They have an open demo page where you can see. In our case, we have something pretty similar to this. Really, this is what Backstage gives you. You can customize a little bit, but this is the main idea behind. And also one thing that is very, very powerful is the software templates. The software templates is a tool that helps you to create components in some Backstage. And we are developing some internally. This is really what we let you to predefine common scenarios or common procedures. No, for example, you can define you can create a template to create a .NET API or a PHP API. This is some examples. We are working in other like Golang because we also have more. We are using more languages internally. But the main idea behind these two templates and any related with that is that it's going to create all for scratch and all the dependencies together. So to avoid having to have meetings and to be talking with a lot of people. So it's going to create, for example, a new application. So it's going to create and configure the repository, the authors for the repository, the responsibles for the repository, and all of that. Also, it's going to create the infrastructure, the Docker registry, the databases unit database, the access to Vault, because we are using granularity access to Vault for each application. So you need to control that. And also the creation of the different Argo applications, because an Argo application is in each cluster. So if you need to deploy to several clusters, you need to create also several Argo applications. Also, something that I show in the right that I think is also good to take into account for the GitOps approach is that we are using a DCL language to create all the infrastructure. So, for example, Backstage, the Backstage that we have deployed, this is only an example. Some of the things are hard-coded. But here, we are going to read with Terraform this file, and we are going to create all the things. No, if for example, the bucket, the new release configuration for the monitoring, the clusters that we go to, for example, the production cluster. So this is really powerful because with the template that you can use with some clicks, it's going to also create this file and pass to Terraform. No? And also we have another change now that we are using Backstage for that is migrate the actual projects that we have some other tools to Argo 3. So for that, we have created a template. That's basically what it's going to do is create the GitHub Actions workflows that we need in the repo, create also the infrastructure that we need with the DCL language, and finally create the Argo application. But this is important especially for the people that we will need to deal with that. it's important to have the autosync disabled by default, because to avoid current conditions, if you are using another 3D tools, the best way that after some tests that we are doing is you have to deploy with autosync, create the application, but with autosync, check, there is a diff like in Git, a diff in Argo that you can see all the results. You can check if all the results are correct, if there is a misconfiguration. And after that, you can apply the change. And obviously, before doing that, you have to disactivate the other 3D tool or delete the flow for the other 3D tool to avoid current conditions. Yeah, another deployment was in a queue, was ready to deploy. And this is the last an example. No, I mentioned that we have some templates for KEDA application. This is the first one. That is select the template. Then you provide the information. Now here is the name, the description, also the team that we assign to that repository, and then it's going to do all actions. Really, a template, what it's going to do, similar to a GitHub workflow, is have like actions that are they are going to be in order, and for that you can use actions predefined as backstage, or you can create your custom actions. And a custom action is at anything that you can code with TypeScript, because this is code in TypeScript, you can do it. For example, if you need some example that also they show is if you need to do whatever with an API that you have internally, you can do. You can pass the input variables to with backstage and do in a programmatic way. Here, what we are doing is we are getting the template. We have a template for these APIs. We are passing the values that you give from input, and we are rendering it with Nunjux. Is the basic functions, the basic action that you can do with backstage. Pass some input, render with Nunjux, and then pass to a repo. Then we are creating the infrastructure as code resource, and we are also creating the Helm resource because we deploy with Helm. Also, we are creating the initial scaffold for deploying in the monorepo. Once that we do that, the application is going to be deployed. And the last one is that we are going to receive a notification like this. Okay, and the last is what we have learned in all this process is that use different tools for the same process is not a good idea, because it makes easier to have knowledge silos. There are only a few people sometimes that know how the things are created, how the things are working. So it's very difficult to deal with when there is a problem. Also, we have realized that giving power to developers helps in their autonomy and make them happy and make us happy. But also we have to take care of this, because if you give them a lot of power, they can make mistakes, as we or anyone can make mistakes. For the moment, everything good, but it's also something that we have in the radar, and we have, it's not here today, but we have a lot of people taking care of the security, and also all the team, of course. And backstage helps you to perform automatic tasks, but in this process that I showed you before, it's a complex process, no? Because it is going to do a lot of things. So the we have unit tests, you can have unit tests, but it's not enough. You have to do real tests on lines, end-to-end real tests to test if the flow is okay, because if the requirements in the company are outdated, you have to update your process to deal with that. So you have to, one good way that we, for example, are doing is we are going to, we are meeting every week or every 2 weeks, depending on the week, and do an end-to-end test. Okay, we are going to create a application from scratch. Everything is okay, everything is deployed, and it's also something to take into account. And also, it's important, as I put this picture, but sometimes happen, to have backup mechanisms, no, and predefined process. We are really taking this into account. We don't want that if everything is back and everything is in Kubernetes, have a problem to restore. No, so we are dealing with mechanisms, with database, with Vault to deal with that. No, so it's also something that you can't forget, or it's important to don't forget. Okay, and this is all. I don't know if there is some questions.
I see no questions asked. So if you got any, just post them and Sean will answer them after Jorge's talk. So yeah, we got to the shore with GitOps theme. Now let's get to the second captain of today. Jorge, stage is yours.
Okay, let me share the screen. Okay. Okay, go ahead. Okay, first of all, thanks to all the attendees just for staying with us here at the middle of the end instead of drinking beers. Maybe anyone is drinking beer at the same time, but not in a bar. So thanks for staying here and for joining us. We are going to talk about scaling applications easily with KEDA, with Kubernetes event-driven autoscaling. First of all, who I am? I'm Jorge Turrado. I'm SRE at Docplanner Tech. I'm also Microsoft MVP in developer technologies. And the most important thing here, I'm KEDA maintainer. So at least 20% of the things that I will say could be near to the reality. Remember, 20% could be a good, accurate number. And in all the slides, you will have my social media, just in case if you want to ask something or you want to check something in my GitHub. Okay. I assume that everyone knows how Kubernetes works under the hood just for scaling workloads, but just in case, I will explain it a bit. We could imagine the typical scenario where we have several deployments. First of all, I'm sharing the correct screen. Yes, right? I'm sharing the slides. Nice.
Yep.
Just in case, better double check it before speaking a lot. Okay, in this, I don't know if you see my mouse. Maybe yes. To be honest, I have to prepare it better. Okay, the typical applications in Kubernetes. You have your deployments, your customer deployment, your order, shipping, warehouse, the typical things that you could have in your clusters. So you want to scale it. And Kubernetes gives us a mechanism just for auto-scaling those workloads. Kubernetes brings the HPA. HPA means horizontal pod autoscaler, and it's a piece of software that runs at control plane side that basically will monitor your application and will scale it based on different metrics. Most commonly, the metrics that are used are CPU and memory. Why? Because it's the default metric server that majority of providers give directly with your Kubernetes cluster. Little remark, little disclaimer, AWS with EKS doesn't give as default metric server. So don't worry, you can install it easy peasy. They have a lot of documentation about how to do it, but just a friendly reminder to me, to be honest. Once we have our HPA, the metrics, the HPA controller will read that manifest, that HPA from the cluster, and just do the queries through the different API, through the different APIs. Which APIs or what APIs do we have in Kubernetes? First of all, just for putting all in the same page, we have the common, the normal metrics API, metrics.kas.io. Yeah, custom metrics under custom.metrics.kas.io and external metrics, blah, blah, blah. The difference between them is basically conceptual. You could expose any metric behind any API, but not important, just for giving a few context. So recapping, we have our workloads, we have our HPA, so the HPA controller will try to get metrics for scaling our workloads. At this point, all is right. Where is the problem? What problems do we have in this case? Okay, the most important reason or the most important point that I would like to transmit today is that you only can have one service behind each metric server, each metric API. That means you can have only one server for normal metrics, for CPU and memory, another one service, and that is monitoring custom metrics, and another one, just three, for monitoring the external metrics. So in a common scenario, in a real world scenario, you could have, okay, I am in Azure, I am running my AKS on Azure, so for me, Azure Monitor is enough. I don't need anymore. Or in the same way, in AWS or in GPC, not important. Never mind, not important, but you are scaling using the cloud provider adapter just for exposing those specific cloud provider metrics in your cluster. Okay, Jorge, where is the problem? You have said that there is a problem. The problem is that you can have only one. What happens if you introduce a Prometheus for monitoring your infrastructure? What happens if you need a Rabbit, for instance, and you would like to scale based on Rabbit? Easy, you cannot. You have to decide. You only are able to have one metric server under custom metric API. So if you choose Prometheus adapter, you are rejecting in fact, Azure Monitor or AWS. Okay, it's not the end of the world. Prometheus can scrape from different sources. So you could scrape your metrics from AWS or from Azure or whatever, not important. But you have to do an extra work of scrapping those metrics, keeping them alive, monitoring, and you are introducing another point of failure, because what's happened if my integration with AWS fails? I have a problem because I don't have any metric. Okay. Why I'm here? Why KEDA solve this? First of all, a bit advertisement about this. KEDA, the main goal of KEDA is making autoscaling simple, simplest as possible. You don't need to think in different complex ways. KEDA automatically works with deployment, jobs, statefuls, or any other, this is important, any other resource that implements /scale. An example of this, my folk Joan told about Argo rollout. Argo rollout is a mechanism for doing rollout, A/B scenarios, A/B tests, and obviously they implement /scale. So KEDA is able to scale Argo rollout, is able to provide a mechanism for scaling Argo rollout, or whatever, not important. If the custom resource implements /scale, it works. KEDA has built in plus than 50 scalers. What is a scaler? And a scaler could be understood as an integration with a different upstream. For instance, CQS is one scaler, AWS CQS, or Azure Service Bus, or Rabbit, or different database providers. We will take a look in the documentation soon, so don't worry, not important. You can do it in your free time. And you can extend KEDA also. Okay, maybe I have to reorder my slides for the next time because I'm thinking that I'm giving a lot of features without giving the main goal. Sorry. For the next time, I will be better, I promise it. The point is that you can scale, you can extend it. We will see how to do it, or I will explain after the call. Don't worry at all. KEDA works with production-grade authentication. We try to provide a real secure piece of software because KEDA is the owner of the biggest of the majority part of the secrets in the cluster. Why? Because KEDA needs access to majority of the services for running. So we try to provide the most secure piece of software that we can. Another important feature is that KEDA supports scaling from 0 and to 0. That is not supported by default by HPA for obvious reasons. I mean, if you scale to 0 anything based on CPU, the CPU will never increase, because if you don't have any pods running, it's impossible that the CPU will increase. Okay, and how KEDA started? How this project started? This project started as a partnership between Microsoft and Red Hat 3 years ago, if I'm not wrong, in 2019, more or less, as a partnership between them, just for creating an easy way for autoscaling in with a lot of different upstreams. And right now, KEDA is a CNCF incubation project. So we are running under, or we are working under CNCF umbrella. CNCF, if you don't know what this is, Cloud Native Computing Foundation, is a foundation created by the majority of the biggest actors in tech world, in cloud world in general, just for having a council and not go to the hell. Anyone could remember the browser wars several years ago. And the most important, KEDA is there just for giving you the option for focus in how you scale your app, and not in the internals of scaling your app. Okay, and now after the publicity, let's see exactly the same behavior that I showed you previously. Now with KEDA. Okay, we have exactly the same deployments. So nothing has changed. But instead of the different, or one of them, instead of one of custom metrics server, KEDA is there. So you don't need to use, you shouldn't use HPA, you should use the own manifest, the own resource for KEDA. What is that resource? Which is that resource? A scale object. A scale object is a CRD developed by KEDA under KEDA APIs. And basically, don't worry, I will show you one scale object in a few moments. But basically, is the way that you have for saying to KEDA how KEDA should scale your applications. So in this case, okay, we have in the same scenario with our deployment. But right now, KEDA is a single server behind one of those metrics APIs, more specifically behind external API. But this time, you don't have to choose between AWS Scalar or Adapter or Azure Adapter or whatever. Why? Because, as I said, KEDA supports all of them. So this scenario, it's possible in opposition to the previous scenario without KEDA. Okay, how KEDA works under the hood? Because, okay, this cool sounds like a huge magic, but there is no magic. There is software under the hood. Basically, KEDA works monitoring your scale object. You create a scale object and you push into the cluster, and then KEDA will receive, because KEDA is actively monitoring scale objects, and KEDA, one part of KEDA, the operator, will create an HPA and directly push the HPA to Kubernetes API. Why? Because we trust on HPA controller. HPA controller is one of the most tested parts of Kubernetes. Why should we reinvent the wheel if we could extend the already trying in thousands of battles components? So we create the HPA. And then another part of KEDA, the metric server, just expose an extra metric based on your scale object. So the cycle is closed. Basically, KEDA creates the HPA with a specific name and also expose those metrics. So basically, the HPA controller will check, will discover the HPA, and will do the request against external metrics API, and KEDA will expose that metric. So at the end of the day, we are scaling based on the metrics exposed by KEDA. What? Give me a moment. I speak quite fast and I need to slow and drink a bit of water. Okay. With this point, or you could think, okay, Jorge, but you told me that HPA cannot scale from 0 and to 0. And that's true. And I also say that KEDA supports from 0 to 1 and 1 to 0. Why? Because if we check this diagram, the scale from 1 to n and n to 1 is done by the HPA, but the scale from 0 to 1 and from 1 to 0 is done by the operator. That means it's KEDA who will scale in and scale out from 0 and to 0 your workloads. So you can scale to 0. You have the capability of scaling to 0. And this is, in my opinion, one of the most amazing features in autoscaling in Kubernetes. You could install it easy peasy if you want, using Helm, using operator framework. And operator framework is for OpenShift. Maybe you know about that. It's the Red Hat flavor of Kubernetes. And you obviously you could install it using kubectl. We provide a manifest. Okay, let's talk about. I promise this is the latest slide before the demo. Don't worry, we will have a bit rest during the demo. But this is important. When we talk about production grade authentication, and when I said we are really engaged with keeping KEDA as safest as possible, it's because, as you could imagine, we have the keys for a lot of doors. We have database keys, we have database secrets if you are scaling based on a database. We have access to different queues provider, different cloud providers for doing things. So even KEDA even KEDA doesn't do any management, because that's true. We don't create queues, we don't create databases. All management things should be done outside KEDA. KEDA just goes to the upstream and execute a query or get a value. But sometimes for recovering that value, you need maybe no administration roles, but more than read roles. For instance, in several queues, for getting messages, you only need read permission, and you read permission. But for getting the queue length, you need extended permissions, because you are not just reading, you are managing the queue. So that's why that is one of the main reasons behind we try to create KEDA as a securest as possible piece of software. And how to do that? Basically, we don't have any secrets as default. I mean, we try to get from secrets or reduce the already existing secrets in the pod. You can directly specify, okay, this secret is in the scaled workload, in the workload that I want to scale using KEDA under this environment variable. So from KEDA point of view, you are not providing any secret. Obviously, KEDA will use the Kubernetes API just for recover that secret and use it. But you are not providing it to KEDA. So if you change your secret in your workload directly, KEDA will take care automatically about that and will refresh all the internal things automatically without any other manual interaction. Okay, and I have talked about, or I said about just reading the secrets from the containers, but to be honest, that is not the best approach. There are other best approaches or better approaches, and we support them. How? we have another, I talk about scale objects. There is another CRD that is known as scale job. If we have time at the end, I will go deeper in there, don't worry. But apart from those CRDs, we have another two CRDs, trigger authentication and cluster trigger authentication. The difference between them is just the scope. Cluster trigger authentication has cluster scope, and a trigger authentication has namespace scope. And that's the only difference between them. Basically, we can create this trigger authentication as a, let's say, authentication component that we can attach in the scale object or scale job, we can attach to our triggers. And with that, we can directly reuse the secrets because we are attaching or we are creating the component just referring one secret. So if we reuse the component in different manifest, in different scale object or different scale jobs, we don't need to duplicate. And if we change in one place, the change will be automatically propagated across all of the scale objects that you have. Okay, but again, I have been talking about reading from environment or reading from secret. That's not the best approach. So taking into account that it's not the best approach, we support right now 4 different pod identities. Maybe you don't know what is pod identity. Pod identity is the mechanism that cloud provider brings for using system managed identities /AMM, AAM, / whatever the name that the cloud provider gives to the mechanism. But it's just like creating an application, a client inside the provider. So even I have the managed identity ID because it's a simple ID. Even I have it, I cannot run using anything using that system managed identity because if I run that locally, my cluster is not federated, connected, authenticated in the cloud provider authorization mechanism. So system managed identity is the most secure option for authentication your workloads. For instance, in AWS, you could use for using it to connect through AWS Kinesis or DynamoDB or any supported scaler. And in Azure side, the same. You could use AD pod identity or AD, I don't remember, never mind. But you could use the Azure pod identity just for get managed identity or for using the managed identity, do the queries against service bus or event bus or blob storage or any scaler. Okay, but if you are running in another cloud, what could you do? Because if you are not running in AWS or either in Azure, you cannot use pod identity. Okay, we have native integration with Hashicorp Vault. That means you could store your secrets in Hashicorp Vault and just go to KEDA and say, okay, using this token, go through Hashicorp Vault and read the secret from this path. Or if you are, or if you have to run in the most secure way that possible, you could directly whitelist or authorize KEDA's service account in Vault. So that will be the most secure way because you are not managing tokens at all. Basically, using using Kubernetes mechanisms, you are gonna authenticate KEDA in your Hashicorp Vault just for recovering the secrets. And quite similar for Azure Key Vault. Okay, let's do a demo and breathe a bit. So, okay, let me close my Slack to avoid potential information leaks. Nice, and the same with the mail. It wouldn't be the first time, so let's be clever this time. Okay, first of all, let me extend a bit because I have talked a lot using slides, but for me, it's better if we go to the code. First of all, about the scalars, you can go to keda.sh and tapping in a scalar, you could see the amount of scalars that KEDA supports. So you don't need to do any extra work just for using any one of these. Apart from that, I said that KEDA supports extensibility. It's done through external scalars and metrics API, just a super fast description. External scalar is a gRPC server, so you could implement gRPC client and just interact with the server using gRPC. Interesting thing for I don't know whom, not for me, sorry. But you also do using metrics API. It's exactly the same. It's the same idea, but in this time with an REST API. So you could expose your metric, put an authentication there, and just say together, okay, go to my server, just for getting the metrics. But just the small disclaimer. Okay. No, deploying is really, it's quite easy. Concepts about KEDA, as I said several times, the scale object. Okay, let's take a look to a scale object super fast. I will explain more deeper or a real scale object in the demo. But a scale object has an specification, metadata and status, obviously, but you have to specify the monitored or the scaled, the workload that you want to scale, and there are several default values, like you don't need to specify that it's apps/v1 or deployment, because are the default values. Never mind. You can specify the minimum and the maximum replica count that you want to work between in your scaling, 0, 1, from 10 to 20, based on your requirements. And another super nice feature that KEDA brings over HPA is that, well, maybe not over the HPA, because HPA doesn't have this capability of going to upstream. What could happen if your upstream is down? Imagine that you are doing queries to a Prometheus server, and I don't know, Joan was there doing his tries with Argo CD, and okay, the server went down and you don't have Prometheus. It's a drama, because okay, what will happen? You will scale to 0? No, you can directly specify a fallback mechanism. If you cannot go to the upstream 3 times in a row, just set 6 replicas and keep it safe, at least until we discover why Joan broke our Prometheus server. Obviously, I'm kidding. This didn't happen, and I hope that this will not happen again. ¿Verdad, Joan? No, I'm joking. Obviously, I'm joking. You also have an advanced section, because if you had fight with autoscaling, you already know that scaling out is super fast. Kubernetes is super aggressive scaling out, and super safe, super conservator. I think that is not the correct way. The correct word is scaling super slow, just because, okay, when you are scaling out, you are adding power. When you are scaling in, you are removing power. So you need to think better when you are removing power. But if you have faced with that situation, you will know that HPA has a specific way to be tuned, saying different behavior during the scale out, during the scaling, and those things. You can do it. Just a mark in the corner. And the last part is the triggers. The triggers is the place where you can place every scalar. So let me show you one scalar, one super easy scalar, RabbitMQ scalar. RabbitMQ, I hope you know about it. It's a Q's server, nothing interesting and nothing special under the sun. But it's the example that I will use. Basically, this scalar requires several data, and you can find which data is needed for its scalar in the specific scalar documentation. In this case, RabbitMQ, it needs a host that could be provided in other ways. That's why I said that this is optional. Protocol, if you want to scale based on QLEND, or publishing rate, or different things, different information that you could check in the scaler. But the most important thing here is that focus on this line. Triggers is an array. It is not an object, it's an array. You could have, in fact, probably you will have more than one trigger for your workload. Why more than one? Because you could want to scale based on Rabbit, but also based on CPU. I don't know, maybe you have another metric from AWS or from Azure Monitor or New Relic or Datadog, or not important, that you could use. So remember that you could have more than one scaler per trigger or per scale object. And again, I have talked a lot. Let's see a super simple demo. I have already deployed KEDA on my cluster. So I will deploy the consumer. What is the okay, first of all, I promise it's not more documentation. It's just the link or the repository of this demo. You can go to KEDA core in GitHub, and the demo that I'm going to do is basically this demo that you can see here, and it's done based on Rabbit, just for giving the possibility of running in your own cluster, even if you run this on Minikube or a Docker cluster. Not important because it doesn't have any external dependency. You have here the step-by-step guide, so you can go through this README and try by yourself and play with KEDA. But basically, this has a secret. This secret is the connection string. Nothing interesting is the connection string to the Rabbit host. We have one deployment. Okay, I did a mistake with this line. Okay, we have one deployment, nothing interesting. It's a demo deployment. It's a demo container just for consuming messages. And here is the magic. I don't know if the screen has enough zoom. Let me do, well, maybe one less. Basically, we have a trigger authentication just for reducing the connection string. And we said, okay, the trigger authentication will has to take the value from secret. So basically, trigger authentication will expose a parameter named host. This parameter should match with the parameter that is waiting the scaler of the trigger, and that value is in this secret under this key. So this key is the exactly key where the connection string is. And coming back to the scale object, okay, let me remove this because it's another feature that I will explain if we have enough time after the meeting. Basically, the scale object, this is the minimum or super simplified scale object just for not going deeper and deeper and deeper. But taking or reviewing it, basically we have the max replica count in 30. These values are just for improving or for speeding up the demo, so don't worry, ignore them. We are specifying the max replica count. If we don't specify, max replica count is 100 and min replica count is 0. So basically, we are going to scale based on Rabbit, based on the queue name hello, and we are going to scale from 0 to 30. So let me apply this manifest, kubectl, apply -f, deploy customer. Okay, and if I go again to my cluster, I can see that I have the Rabbit server, the Rabbit server, and I have my consumer scaled to 0. I have my HPA. Don't worry about unknown. This is a known limitation in HPA. It's because if you don't, the HPA try to do some mathematical operations, and if the replica count is 0, every number divided by or divided by 0 is an error. So don't worry, it will work, I promise. And the last thing is the trigger authentication and the scale. Nothing complex. Okay, so let's try the demo. I will put this job just for enqueuing some messages in the queue. Again, it's a super simple image. You can go to the KEDA repository and watch it. It's basically a consumer and a publisher. And I will publish it. So I think that right now it's working. And let's see, right now, instead of 0 replicas, we already have 1. So automatically, KEDA has scaled the deployment. Right now, let me check. 4 instances we are consuming. We were with 0 instances in a 0 instances scenario. And right now, we are scaling out properly. And we will scale out till 30, if I'm not wrong. And if I came to here, to the HPA, I can see that this is working and it's working good. Okay, maybe you'd notice that I delete one annotation. What is that annotation for? Recently, we have introduced a mechanism in KEDA just for pausing the autoscaling. Why could you want to pause the autoscaling? For instance, in maintenance operations. Imagine that you have a worker that is overloading the database and you need to scale to 0 directly. If I go to here and I take this workload, okay, let me try it again because the messages in the queue has finished. So we don't have any message for being proceed. Delete and re-enqueue the job. No problem. It's free. It's for free. And if not, I will pass the bill to Docplanner. So don't worry. No, I'm joking. Obviously, that's a good point for using Rabbit because it's local deployed and it's totally for free for doing this try. So basically, I will add the annotation. First of all, as I said, let's think, okay, let's scale to 0 because we have hard load. Okay, I have scaled them to 0, but suddenly one more instance was created. Why? Because KEDA is monitoring the workload. So you need to tell to KEDA, okay, I want to have only 0 instances. How can I do that? Using the annotation autoscaling.keda.pause replicas and setting the value. For instance, imagine that you need to scale to 1 because it's not good. It's not worth for you if you scale to 0. You need a minimum compute power. You can do it. And if we come here, we can see, or we see that right now I have only 1 instance. Let's do again and put zero. So basically, KEDA has killed my deployment. In the same way that I put 0, 1, you could put 100. It's your decision and your responsibility, obviously. Don't open an issue. No, I put 0 and I scaled to 0, my production application. That's your fault. In the best case, you could say blame to Xuan, but it's not KEDA fault at all. So remember this. Obviously, I'm joking again. But it's not KEDA fault. So if we delete this one, okay, now the application will start again and do things that are interesting, but I think that is not necessary. Just being here, watching how empty or dummy messages are consumed. Okay. Before continuing with the other parts, let me go deeper in the scale job, scale object, because it's a really interesting thing. And before joining KEDA, I didn't know about the scale job. And to be honest, it's a really good thing. what is a scale object? What is a scale object for? Okay, I told about the scale or a scale job, sorry. I told about the scale object and I said, okay, you can scale your deployment, your workloads from 0 to whatever. And that's true. The point is that it's the HPA controller who decides which pod should be killed. So that what that means? That means that you could be running a long-term process because your business requires to, I don't know, instead of processing 1 billion of messages per minute, you only need to process 1 message per minute, but that message needs 3 hours. Imagine that the HPA controller decides to kill the pod that is running your long-term process. That could be catastrophic because, yeah, it's true. The message will be re-queued and will be processed by other pods, but you have lost several hours just for doing nothing because the job is lost. Scale job is the other point. Instead of scaling your deployment, we'll spawn jobs based on metrics. What that means, imagine that you have the previous scenario that I told. You have a message that create the KPIs for super important part of the business and it needs up to 1 hour. Okay, you could create a process that runs as a job just for doing that. And you could use scale jobs just for saying, okay, KEDA, spawn jobs and jobs will take care about those messages. Why? Because KEDA will not kill any job. KEDA will clean up the completed jobs, but once a job has started, it's the job who has to finish successfully or with error. But KEDA will not remove any in progress job. And this is important because there are not all the workloads are super fast, and that's true. So go to KEDA concepts. If you are interested on this, you can go to the documentation. To be honest, it's a good documentation. I couldn't do it in this way, but that's why I'm not the guy who designed the docs. Hopefully for users. And basically the scale job is quite similar. You have the triggers, you have in the max replica count, but instead of having the target reference, the workload reference, you have to define the job. You have to define here the job. You have the whole job spec here, and you have to define directly here because KEDA will take this spec and will spawn different jobs based on the messages. There are some configuration for the historic, the history, maybe how another things that you could, if you need this, you could take a look. What is a job? What is pending for being considered as running? But at least my goal with showing this is just to give you the knowledge about, okay, scale jobs exist and exist for one thing. Okay, let's go again to the demo. We are finishing, I promise. What about HTTP autoscaling? In KEDA, as part of KEDA Core, we want to provide a real first grade or first class support for HTTP autoscaling. Right now, it's a different scaler outside the KEDA Core. It's part of KEDA Core organization, but it's not running as a built-in scaler. You need to deploy another chart, and based on the extensibility of KEDA. Have I muted myself? Can you hear me? There is
yes,
one.
We can hear you.
Okay. I said because there is one attendee that I wrote. He can hear me. Sorry, Alejandro. Maybe any one of you could answer him. Okay. Coming back, the autoscaling. We take care about, or we use the extensibility okay, they are giving tips. We use the extensibility of KEDA just for creating another application. Important thing, the most important thing is in beta status. So don't run it in production or do it under your own risk. And this is important disclaimer. But we support this scaler, this add-on brings first-class support for HTTP scaling. What that means? That it's all inside the add-on. You don't need to spawn another Prometheus and scrape the metrics from I don't know where. And no, you are gonna do it all the things inside the add-on. It support ingress or no, it support only service. Sorry, we are working on support the most common APIs for routing the traffic. And giving you another diagram about how it works. Basically, it creates another CRD that is a HTTP scale object. You can spawn it, and automatically the HTTP add-on will create an scale object pointing to HTTP external metric server and those things. So basically, you only have to route your ingress to the service, to the service that KEDA HTTP add-on creates, and basically that service is routed to the interceptor. The interceptor is sending metrics about the usage to the external server, to the external scalar server, and it's proxy passing the request to your deployment. So basically, the metrics are are collecting in real time. And just for finishing, because maybe you have questions, and if not, at least I will give you some time. The question: should we trust in KEDA? KEDA is a group of friends doing things, or has some support, or what is KEDA? How is KEDA going in community in general? Okay, again, I have to update these slides because right now we have 5K stars on GitHub, not 4.9. It's not a huge difference, but between 4 and 5, looks better. 5,000 stars on GitHub, and the contributors are quite heterogeneous. There are heterogeneous is correctly in this, the type of the companies that contribute to KEDA is really different. We have small companies, we have biggest companies, we have companies in the middle, we have standalone or single contributors. And for instance, one of those companies is Microsoft, another is Red Hat, another is we are another contributors, call it AVM. So answering my own question, no, KEDA is not a project driven by a group of friends without any responsibility. We are working on this. As far as I know, Red Hat is creating a product based on KEDA for OpenShift. And yesterday, Satya Nadella, the CEO of Microsoft, announced that container apps in Azure are in general availability, and they run using KEDA for autoscaling. And they offers it publicly just for your workloads in Azure. So no, it's not a group of friends, it's a real project, it's a serious project under CNCF umbrella. And these are some of our users. And again, maybe you could say, Docplanner, you are a small company. Yeah, it's true. Depending on the other part of the comparison, we could be a big or small, but it's true. I can assume it. But Alibaba Cloud is one customer. Zapier is another customer. Microsoft. So it's a real product. The most important thing is community-driven or community-driven project. So feel free to join us on every weekly. We will be super happy having new folks and having new contributors because this is a community project. You can find documentation about the community things, basically in, again, oh surprise, in KEDA.sh, our website. And apart from that, that's all from my side. I don't know if you have any question. If not, we have 3 minutes or 5 3 minutes just for, I don't know, making jokes about why Joan will not destroy production again, right? No, I'm joking, obviously.
Yeah, so in case of any questions, post them in the QA section or in the chat.
I
And if
cannot
you're
see,
writing,
I
yeah,
can't
but
see anything.
yeah, if you're writing a long question, just give us a sign because we're not gonna stay here in silence forever. So just we know that you're preparing your question.
Yeah, I put again the presentation slide. Again, remember, these are my social networks. You can directly ask there. You can send me a message on Twitter or whatever, and I will ask it. I promise. We try to take care about our community. We are so proud about community.
Yeah, and while you're ingesting what Jorge has just told you, let me just add that unlike many other tech companies, we've got our positions open, including SRE area. So if you're interested, come visit our Docplanner Tech page that has just been pasted to the chat. We're also looking for some new forces in the data engineering area, which I'm a part of. So using this occasion, let me recommend applying. Yeah, in case.
Yeah, sorry, that's true. If you are interested on the things that we have explained, this is not a support. These are real applications that we use on production. So if you are interested on this, maybe you want to join us just for getting experience, for getting real in production experience with these tools.
Yeah, so no questions asked. Well, oh, we've got one. That's for you, Jorge, I guess.
Question where? No question.
Well, it's not a question, it's just some kind words.
Thanks. But I have done the less work. Community has done the biggest work, the majority of the work. We only are here just for putting face and get the kudos.
Yeah, anyways, thanks so much for your participation, folks. Thank you so much to the speakers. It was nice meeting you all.
You're welcome.
You're welcome.
Have a good evening.